went well. It was probably just a little bit long. Especially if you didn't read the directions at the top where it says you can use your calculator to evaluate the function. David was like, what? That's why I put things like in bold. If I could get it to blink at you on the paper, I would. Alright, so 1, 2, and 3, you guys had to choose 2 out of the 3. So f of x equals some cubic function. I take the derivative. I set that equal to 0, 8, and negative 2. I build a number line. I can see I've got a relative max at negative 2. I've got a relative min at positive 8. Not the answers. I then take my 2 candidates and I evaluate the original function at those 2 internal candidates of negative 2 and 8, as well as the endpoints negative 5 and 10. I did all that nastiness by hand because I like to show off sometimes. And I get an absolute max at negative 2, 104, and an absolute min at 8, negative 396. How'd everybody do? Mostly okay? Now here's my question to you. Why do we even do this to find the absolute max and the absolute min? Why on earth would we do this? Because I'm trying to kill you, maybe. Paimon?
So we have to understand where the max is, the highest point.
That could be a thing. If you had a graph in front of you, would anybody go through this process to find the absolute max and absolute min? No. What would you do? You tell there's the highest point. Oh, there's the lowest point. Done. Move on. But in the absence of a graph, what you're left with is your really powerful calculus skills, which is why we're going to take the derivative and we find our critical points. You find where the derivative is equal to 0. You find where the derivative is undefined, and then you're going to go through and you're going to evaluate the function at your candidates and at the end. Everybody okay? All right. Aaron, you okay? Oh, okay. All right. Number 2, you take a derivative. You should get plus or minus 2 as your candidates. I did a little number line test. I see that my derivative changes from positive to negative at negative 2. Somebody tell me, why am I not interested in positive 2? Why am I not using positive 2 here, Andrew?
Because it's not in the closed interval.
It's not inside that interval that I'm interested in, so why bother looking there? I'm only interested from negative 3 to 0. The domain restriction matters. From here, evaluate the function at negative 2, evaluate the function at negative 3, evaluate the function at 0. According to my beautiful work, absolute max at negative 2, 128, absolute min at negative 3, negative 3.
Yeah.
Everybody's okay? Good. All right, number 3.
No.
Am I asking number 3 again?
No.
4.
4.
Wait, are you going 1,
Oh,
2, 3?
I don't know what I'm doing anymore. Okay, number 4, f of x equals x squared minus 8 natural log of x in the interval 1, 4. Now the function's getting a little bit nastier. You're going to take the derivative 2x minus 8 over x. When you set that equal to 0, you all join my gang. We're in the fraction killer club. We multiply by the common denominator. Not sure why that's funny. That club is always accepting membership. Okay, I heard you guys once were like, what, right-hand rulers? Right-hand rulers, now we're fraction killers. Especially if you need a letter of recommendation from me, you're going to join my gang. Alright, so you're going to solve this equation. You get negative 2 and positive 2. Negative 2 is not in the domain. So I'm not interested. I evaluate, I evaluate, I evaluate. Absolute minimum at 2, 4 minus 8 natural log of 2. Absolute max at 4, 16 minus 8 natural log of 4. And there's no way you're going to evaluate those two numbers in your head. You're going to have to go to the calculator. All right. Number 5, take a derivative. Ooh, trig. Daddy likes the trig. Okay, derivative 1 minus 2 cosine theta. Set that equal to 0. Solve it, pi over 3 and 5 pi over 3. Evaluate the original function at pi over 3 and 5 pi over 3 at 0 and at 2 pi. Conclusion, absolute max at 5 pi over 3, 5 pi over 3 plus radical 3. Absolute minimum at pi over 3, pi over 3 minus square root of 3. Aaron, you okay? You look so focused on Mr. Link right now, it's kind of creeping me out. Oh, okay. There we go. I know.
Oh, once you answer some problems right.
Well, that's going to take a long time. Alright, so, alright, number 6, go through. You're going to have to do a quotient rule for those of you that like the quotient rule. And I think you get x equals 1 and x equals negative 3.
What is this for?
to go to college and get a good grade, and find some pretty lady to get married. Number 6, 1 to -3. H of 0 is 0, H of 1 is 1, H of 3 is 0, absolute maximum at 3, 1, absolute minimum at 2, count them 2 places, 0, 0, and 3, 0. Carmen.
Isn't it absolute max? X?
Isn't it an absolute max at, oh, awkward, have your pen, absolute maximum at X equals 1. Okay, Ilay's packing another pen. All right, and you have an absolute min at 0 and 3. Thank you very much for the use of your pen. Okay, everybody feeling good about this? All right, let's put that in the middle of the table and let's get ready for a little quiz, shall we? We're going to get ready for a little quiz. Yes. So quiz number 1 is a take-home quiz that you are going to do this evening.
There's a quiz number 2.
Breathe. Breathe. Okay, quiz number 1 is 8 multiple choice questions. You are going to take it home tonight. You are going to bring it back to me Thursday morning. And you're going to grade it and do all the things.
Thursday morning?
Thursday morning, because tomorrow you're going on a field trip.
Oh, yeah.
Okay, but we have made other arrangements for.
Yes.
Yes. He's your other arrangements. This is due Thursday morning, no exceptions. All right, good. All right, quiz number 2. You get to work with a partner for the next, oh, wait. You know what's about to happen. You're all here.
Oh, someone's gonna work with the
Andrew.
You have, no, get your hands off his nipples. Okay. You have 5 minutes to answer all of these questions to the best of your knowledge. They're in the handout on page 21. I'm looking for complete thoughts, complete answers. You have 5 minutes. You can use your notes if you need to. You may not sit with anyone, you may not work with anyone you are currently sitting with. Anyone who is 5 minutes, make it happen. Giselle does not get the camera.
Andrew does. Andrew does.
Andrew, you know they love talking to you. All right, 5 minutes.
All right. I can talk to them or what?
That would be helpful. They're counting on you, son, to talk to them. Maybe you want to read the question. Maybe you want to share your thoughts.
I don't think I can help them.
You don't think you can help them? Great.
Okay, so what is the difference between relative maximum and absolute maximum? Relative maximum is the highest point that you can see, while the absolute maximum is the highest of the entire graph.
You have the problem set back? Oh.
The relative maximum
Or on the any type.
is anything.
Wait, when I say absolute maximum, I say at the highest point over an interval. Do I have to, but don't I have to adhere to the higher function?
So what's the difference between a global minimum and an absolute minimum?
The difference between
Oh, that's all I was like,
and absolute
yeah, I was
minimum
like, isn't that the whole function is also
is
like,
like,
okay, I'm making sure I wasn't just.
Or you can say when f of x continues from
You actually can't even say on. I just said it's the same thing. So just asking what's the difference.
it's confusing.
You all continue to
Why, hello, Andrew. How are you and your partner doing? This doesn't feel fake at all, does it?
No.
All right. All right. So, do all continuous functions have an absolute maximum and an absolute minimum?
because they can be, but it's just continuous.
If you have a continuous function, do you have to have an absolute maximum? And you would say, no. Can you give me an example?
if it's just
Huh?
Red button, be careful there. If you have a line, is there a highest point? There is a highest point. Can you think of another continuous function where there isn't an absolute maximum?
Okay, the horizontal classical.
How about the graph of e to the x? The graph of e to the x, my perspective, increases from left to right. Is there a highest point?
We just say we're all functions.
Why not?
because they both go straight to
Yeah, 'cause
one of
this-
them is approaching 0, one of the other one is close to infinity.
Okay, and so there is no highest point on that graph because the graph just continues to increase towards infinity. There's no point where like the y value is the greatest. Okay, is there an absolute minimum? Think about that graph of e to the x. You're increasing from left to right. But if you're going this way, like you're getting closer, closer, closer to 0, is there a lowest point on the graph? So that's the thing. I want to keep coming back to this idea of like point. Is there a point, an actual specific point in the graph that you can say, ah, there, that is the absolute highest? In this case, no, there isn't one. And there's no point where there's an absolute lowest. Another example to think about would be natural log of x. Right, that natural log of x graph just continues to increase forever. There's no highest point, there's no lowest point. Okay. See you later, trailblazers and explorers.
This is the lowest one. This is in here.
1 more minute.
Like here, this would be right? The lowest one would be
Actually, this question.
But I know what it is.
Okay, so this one is yes because in the closed intervals, it can when it ends, it's gonna be its maximum, but where it begins, it's gonna be the lowest. It's gonna have a lowest and a highest place no matter what. It's continuous and it has a closed function, so it's gonna have a minimum and maximum.
Not on this one. You're going to say no, and you counter example. Remember, for all of your answers, if you're going to answer no, I need a counter example. All right, Andrew and friends. On a closed interval AB, will all functions have an absolute max and an absolute minimum? You've got a closed interval. Do all functions have to have an absolute max and an absolute minimum? Why not?
Because we know like refer about the natural law,
Yeah.
and we just do like from the same. So if it's like
Hold on, Aaron.
if it takes the natural law like that we do from AB, then
Yeah.
it's just gonna be it's not gonna have no like absolute max or minimum.
So wait, so your graph of the natural log of x, which kind of does this thing with the vertical asymptote, right? So you're saying if you have that function on a closed interval, there won't be an absolute max and an absolute minimum. But if this is my graph of the natural log of x, and I say, here's my closed interval, think of the way that function behaves. It's increasing from left to right. There is going to be a highest point, and there is going to be a lowest point. So there's something else I need you to be thinking about here. The only thing I've told you for sure is that the function is on a closed interval. Aaron, what's up? What do you do when you finish? Excellent. Thank you for letting me know. And let's move on. All right. Huh? Most of us are finished. And Celeste, can you pretend to be Stephen and capture this? All right. Number 1. What's the difference between a relative max and an absolute maximum? Relative max and an absolute max. Palamon.
The absolute max is the highest point throughout the whole thing,
Absolute max says it's the highest point on the graph, and a relative max?
and the relative max is just the high point at a certain point, not the highest.
Really what I want to hear with relative max has to do with the behavior of the function. A relative max is where the function changes from increasing to decreasing, or derivative changes positive to negative. All right, number 2, what's the difference between a global minimum and an absolute minimum? David?
They're the same thing.
Huh?
They're the same thing.
So what's the difference?
There's no difference.
You never answer my questions, do you? The difference is there ain't no difference. All right, number 3, do all continuous functions have an absolute maximum and an absolute minimum? If the answer is no, I need a counterexample. Myra?
No, because it has to be on a closed interval.
Okay, so I agree with you that the answer to number 3 should be no.
Natural.
Okay, you're a very good listener. Okay, so for example, the graph of y equals the natural log of x. Is that function continuous?
Yes.
Absolutely. Is there an absolute max?
It could be.
No.
No.
The way I've drawn this graph, is there an absolute max?
No.
No, because
It's not gonna close the
Keep
window.
going.
this graph continues to increase. That's why there's no absolute max. Is there an absolute min?
No.
No, for the same argument. Maybe you wanted to use, for example, the graph of y equals x cubed. Again, no absolute highest point, no absolute lowest point. This is the thing. All right, good. On a closed interval, will all functions have an absolute max and an absolute min? Stephen, what you got for me?
No,
Why not?
because, for example, function 1 over x.
Oh, good thinking there. Here's the graph of y equals 1 over x. Yeah?
And if you use the interval of -1 and 1,
Okay, so here's x equals -1. Here's x equals +1. You're saying there's no absolute max and absolute min?
no.
Why not?
Because, for example, well, it goes all the way to infinity on, well, negative infinity and positive infinity when you approach 0.
Right, as my x values approach 0, the y values decrease towards negative infinity and they increase towards positive infinity. So although I tried a continuous function, and then I tried a closed interval with a discontinuous function, I'm not guaranteed an absolute max and an absolute min. Question number 5, can a function have a relative max which is not the global max? Relative max that isn't the global max? Yes, and when I walked around I saw a lot of folks that had something maybe like that. Right, here's your A max, your absolute max. This guy over here is your relative max. That's not an absolute max, so that's possible. And then number 6, as completely as possible, state the extreme value theorem. Aaron, land the plane here.
The EBT states that all continuous functions over a closed minimum, over a closed interval will have an absolute minimum and maximum.
Everybody okay with that? If you have a continuous function on a closed interval, you have to have an absolute max, you have to have an absolute min. Number 3, all I told you is the function had to be continuous, but I didn't give you a closed interval. Number 4, I gave you a closed interval, but I didn't require the continuity. When you get both, you have to have an absolute max, you have to have an absolute min. Everybody okay? And Aaron's wondering like when his lifesaver is coming. I know. All right, let's get you guys all back to your like usual places. Stephen didn't go in? And here.
I don't know where mine was.
Here. Here, Giselle, incoming. Don't even scream out loud.
What? How do you trade?
All right. Now, now life gets good. I need you guys to have your calculators out. It's today. We're starting it today. Optimization.
He seems excited, I'm scared.
This is where I broke everyone last year. I snapped the teenagers in half last year in this topic. It was freaking awesome.
Would that be you in half this year?
But this year, I've got it right. I've got the right kids. I've got the right problems. All right, 1 out of 2 is not bad. All right, we're going to do our first optimization problem. And here's how they're going to look. Here's how they're going to feel. Okay, a sheet of cardboard 2 feet by 2 feet is going to be made into a box by cutting equal-sized squares from each corner and folding up 4 edges. What will be the dimensions of the box with the largest volume? This is how these problems are going to feel. Now, When I read a question like this, in my head I'm thinking, oh, this is an optimization problem because I am trying to find like the best solution. I'm trying to find like words that really like pop out for me. Like largest. I think like when I see the word largest in a calculus setting, I'm thinking, oh, you want me to be thinking about optimization because largest implies absolute max. I want the absolute maximum volume possible for this situation. So even if I don't use the word absolute max, is everybody okay that we're looking for an absolute max? Now you might think, well, there's lots of ways I could make this box. It's 2 feet on this side, it's 2 feet on this side. The goal is here to cut out the little corners and fold up the sides to make a box. There's lots and lots of ways that you could do this. What I want is the one that has the biggest volume. What I want to do is give you guys a little bit of time, see what you can do as a good start on this problem. We'll talk a little bit. Trust your smart particles. Maybe you want to start by like drawing the box that we're going to make. So if I think about this 2 feet by 2 feet piece of cardboard, I'm cutting out the corners, right? Because I need to be able to like fold those sides up. And if I have cardboard here, I can't fold them up. When we cut out those corners and we fold up, what are the dimensions of the new box?
3.
What was that, Myra?
3.
3. Where's the 3 coming from?
Oh, she's saying it's a 3D box.
Oh, it's a 3-dimension. I understand now. Dimensions. I want to know the length, the width, and the height of the box. Anybody know anything about the length, the width, or the height of the box? How the moment you got?
We just know that the length is going to be less than 2.
The length is going to be less than 2. Is everybody okay with that? The length has to be less than 2. I think we can do better than less than 2. I think we can actually come up with an equation or some way to represent this. Stephen, what you got for me?
5/3.
Pardon?
X equals, wait, no, I mean, the height is 5/3,
The height is 5/3.
or length.
We're going to come back to you in a little while. David?
I think you need a better answer.
Okay, so, all right, so I've heard 5/3. No idea where that came from. I've heard 2 minus x. Lewis, what you got?
2 minus 2x.
2 minus 2x.
Yeah.
Oh, yeah.
5/3. Anybody?
Sorry, Steve.
Yeah, I have no idea where that's coming from. 2 minus x. 2 minus 2x.
Sure, buddy.
Okay, what was the mistake with 2 minus x, David?
I forgot the other side.
Right, you're starting off, this guy here, this whole length here is 2 feet, and you're knocking out this side here, and you're knocking out that side there. That's why the length has to be 2 minus 2x. That's the length. The width?
Oh,
The width is also 2 minus 2x. What's the height? Think about what you're doing. You're knocking out these corners, you're folding up the sides.
No, 2 minus 6.
The height is actually x. The height is x because when you think about this little square that you're cutting out, the length of the square, think about what happens. You fold it, that becomes the height. So I'm folding up the sides. I now have a length of 2 minus 2x, I have a width of 2 minus 2x, and I have a height of x. What's the volume? The volume is we're going to multiply them together. Okay, so we've got 2 minus 2x times 2 minus 2x times x. My goal is to optimize this. My goal is to make this volume as big as I can get it to be. My question for you all is, does there have to be a maximum value? Must there be an absolute maximum value for this function? If so, I need to be convinced. We already know not all functions have an absolute max. There has to be something that you know about this function that screams there must be an absolute max. Celeste, what do you know?
That the function is continuous.
This is clearly a continuous function. You've got a polynomial. V is continuous because a polynomial. So that means that there's a maximum?
It's continuous on a closed interval.
Now, closed interval, Lewis, do you see the closed interval?
Since x is less than 2, the closed interval has to be less than 2.
So I hear you saying x has to be less than 2. Now here's the thing. That doesn't get me a closed interval. A closed interval means you have a lower bound and you have an upper bound. Think about this problem. Is there a lower bound for the x? What's the smallest square that you could cut out of this? Think about this. Think about that piece of cardboard. What's the smallest value of x that you could have? The smallest value of x you could have is 0. What's the greatest value you can have? Not 2.
1.
Not 1.99.
1.
Think about what's happening. That x represents the length of the square that you're cutting out. The cardboard is a total length of 2 feet long. You have to cut out from both sides. So the biggest value is 1.
This from both sides.
Because you're saying come in from 1 foot on the right and 1 foot on the left, you'd be meeting in the middle.
Only do one side and do 2.
Are we okay? Continuous function, closed interval. Does there have to be an absolute max? Yep. So I'd say therefore EVT applies. So you guys know exactly what to do. You've got a function. You get to use the EVT. What are we going to do? Oh, painful. We're going to take a derivative.
You didn't do it already?
We're going to set that derivative equal to 0. We're going to get our candidate. We're going to evaluate the function at the candidate. We're going to evaluate the function at the endpoint. Now let's be clever about this. One option for taking this derivative? Product rule. In fact, extended product rule. Another option for finding the derivative here, Aaron?
Write it out.
Write it out. What do you mean?
Like I already simplified it.
Okay, I think you meant like you multiplied everything out. Right, there's some advantage here of doing the algebra before you do the calculus. If I do that, 2 times 2 is going to be 4.
4x squared minus 8x
4x cubed
plus
minus
4. No, not yet.
Okay, hold on, let me just multiply that out. So we're going to get 4x minus 8x squared plus 4x cubed. That's my volume? Yeah, that's right.
Oh, you wrote it back. I was like,
Yeah, if you want me to write it in descending order, I'll do that. 4x cubed minus 8x squared plus 4x. Okay, now we're going to take the derivative. 12x squared minus 16x plus 4. We're going to set the derivative equal to 0. Now I've got a factor. 12x squared minus 16x plus 4. I think I was kind when I created this problem.
4 take out
So I can take out a 4. 3x squared minus 4x plus 1 is equal to 0. I've got a factor. I think that factor is just 3x minus 1 times x minus 1. And so I've got x equals a third, or x equals 1. Is everybody okay getting down here? Here's what I hope. I would expect that if I started you here, if I gave you the function and said go find the absolute max or the absolute min, we just plow all the way through with this, right? What makes the optimization problems hard is you're going to start with the situation, you're going to have to come up with your equation that you're trying to optimize. So this guy here, the original is called your optimization equation. Right? It's the thing that you're trying to make as big or as small as possible. Sometimes there's going to be a domain restriction that you're going to have to figure out. Other times it'll be given to you. The work we did yesterday, you were given everything. The work we're doing now, you're going to have to do some work to pull it all together. But really, like, my expectation is once you get here, you're almost on autopilot. Take the derivative, set it equal to 0. Great, I've done that. Next move. There's really only one move left. You could do the number line test for short.
You don't have to.
You really don't have to. What's the thing that I'm looking for? I want the absolute max. I have my candidates. My candidates are 1/3 and 1. In fact, really, I don't have two candidates here. I only have one. The one that I want is x equals 1/3. This guy is like one of your endpoints. And then your next move, you're just going to say, all right. So now let's like evaluate v at candidates and endpoint. Okay. So volume at 0, volume at 1/3, volume at 1. Volume at 0, we go all the way back to the beginning. 2 minus 0 times 2 minus 0 times 0 is 0. Hopefully this one makes sense. Right? Myra, why does this one make sense to you? If x is equal to 0, what you're saying is I didn't actually cut a box out of the corners, so I can't fold my sides up. Okay, volume at 1/3, you're going to have to do a little bit of work here. 2 minus 2/3, 2 minus 2/3 times 1/3, that's 4/3, that's 4/3, that's 1/3. I think that's 16 over 27.
Sure, we'll take it.
And if it's not 16 over 27, I don't really care right now. And plug in 1, what's the volume going to have to be here?
0.
Somebody convince me why this has to be 0. Why does this have to be 0? Think about the situation. What did you do?
Oh,
So that's what happens.
you cut off one from each side so that it's essentially, there's no like box. Like,
Right, when I made my square, I cut off a foot from this side, I cut off a foot from this side to make my squares. I throw my squares away and I say make a box.
And the squares are the one.
Right, the square. I have nothing left.
Boom.
Boom.
Me either.
You're like, I'm empty. Everybody okay? Okay. So here's the thing. What we know is this must be the absolute max. But answer the question. What are the dimensions of the box with largest volume? Resist the temptation to say 3 again. Yes, it will be a 3-dimensional box. What are the dimensions? What I'm looking for here are length, width, and height.
Oh, first one.
The length is 2 minus 2/3, which is what, 4/3. The width is 2 minus 2/3, 4/3, and the height is 1/3. Did I ever give you guys units? Feet. 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 Everybody okay? Anybody interested in making your life a little bit easier? Yes. Okay, take out the calculator. That too.
He's gonna show us how to do it, and then we're gonna have to sit
Did I say that? No, I didn't say that. What is this? What? What? Oh, that's Mr. Link. All right, if you guys can graph the derivative function.
Got the test servers.
Sorry, test scores going.
Oh, my grades. You guys think it doesn't affect us.
Oh no. All right.
graph the derivative.
Graph the derivative function, please.
Type in half the derivative.
All right. We're going to graph the derivative. Okay. It was 2 minus 2x. No. It wasn't.
The derivative?
What, Aaron, what was the derivative?
12x squared
12x squared
minus 16x plus 4.
minus 16x plus 4. That's the derivative graph.
C.
We've got restricted domain, right? We said we're going to go from, was it 0 to 1?
0 to 1.
0 to 1. Okay. So this is V prime. I'm so excited about this. I've never taught optimization this way before. I'm curious to see how well it goes.
Me too.
So it's like, please don't break us like you did last year's class. Knowing that this is the derivative, does anyone see any evidence that the volume has to have a maximum? One person. Looking at the graph, know that this is the graph of the derivative. Is there any evidence here that the volume has to have a maximum somewhere? Don't talk to me, talk to your neighbors.
Yeah, I know.
Wait, is the
Wait, I literally did not
is the y?
You know what? It's negative.
What's y?
Your x-axis is like the width of the box that you cut out. The y-axis is the derivative of the volume. Is there any evidence that there has to be a maximum polymon? Where's your evidence coming from?
From the old rules that we know.
The old rules. So like the old country?
Yes, the old country.
Going back to the old country, okay. In the old rules, tell me more about these old rules.
If for the derivative, if it's going from positive to negative, that there's going to be a maximum at the point at the end.
Okay, over here we know V prime is positive. Over here we know V prime is negative. Are we okay with this? What's happening over here? You're changing from positive to negative. If V prime changes, since V prime changes from positive to negative, what do we know about V? But you have to be careful now. You have to be really careful. What kind of max? What we have, not a straight max. What we have is a relative max. The adjective makes a difference here. V has a relative max. Well, where is that relative max? Go find it. You can get your calculator.
Just say 1/3 and 1/3.
That's not what your calculator is going to tell you.
No, let's say 1.33.
0.3333.
0.33333 on the calculator? Are we actually getting 0.33333 in the calculator?
Yes.
Okay, so at x equals 1/3. Here's the part that's even better. If you have the graph of the derivative in front of you, if you can make this argument work, you can also convince me that this relative max is and must be an absolute max. What's the volume graph doing? What's the volume graph doing from 0 to 1? The volume graph starts off at some point over here and then does what? Uh-oh. I heard increases and decreases. Right, this is the graph of the derivative. Tell me about the graph of the volume function. The volume function is increasing and then decreasing. If that's the only thing that the volume function does, I wish I had a good other color, right? So in orange, if I'm like, hey, let me sketch the volume function starts off here, it increases, and then it decreases. Could this be anything other than an absolute max?
No.
If all my volume graph does is increases, and then it decreases, I can never get higher than this point. Ever, ever, ever. So the strong conclusion is to say something like this. Since V prime changes from positive to negative at x equals 1/3, but has no other changes, for 0 less than or equal to x less than or equal to 1, V has to have, or V has an absolute max at x equals 1/3. If you can pull up this argument in orange, and I'll repeat it so you can get this, Lewis. Okay, the argument in orange, if you can really pull this off, there is no need to check endpoints. There's no need to do a number line test. You just know, because you have the graph of the derivative, My derivative went from positive to negative. My volume function therefore went from increasing to decreasing. That's all that it's allowed to do. This isn't just a relative max, it has to be an absolute max. Everybody okay with this argument? You're going to get some practice with this, you're going to get some at-bats. You got to be careful though. If your graph went from positive to negative to positive again, even for just a little bit of time, this argument doesn't work anymore. Just think about what would happen. That would allow your volume function to increase, and then decrease, and then increase again. If your volume function gets to increase again, even for a little bit, is it possible that your volume gets greater than it is over here? I want to ask that question again. If the derivative goes from positive to positive again, that means that the volume function is allowed to go from increasing to decreasing to increasing again. Even if it only happens for a little bit of time, you could conceivably get up higher than you were over here. Everybody okay? Yep. All right, see what you can do with the next one. Yeah.
The top was open for the one we just did.
Right, the top was open on the one we just did. David, you okay? Here, so how are the friends over here doing?
Huh?
We're going to get lots of practice Thursday and Friday. We're just going to continue in this world of optimization. Because the hard part is always going to be going from here to like, what's the function? What's the thing I'm supposed to do? And I bet for the 11 of you, once you get to the function, just autopilot kicks in.
You did 2 minus x, didn't you?
Surface area means it's the whole thing.
The volume is x.
It's surface area. Surface area means the whole
Actually,
thing.
yeah.
No.
It's surface area, which means we will not going to count the bottom or the top to this hollow top. We're just counting the 4 sides. X times y and 4 times. X times y is 100.
Volume is x squared times y.
Surface area. The 180 is the surface area. The surface area is what we're going to use to find the limits of x and y.
Where's it all go?
Well, I don't think you need to.
Surface area is the 4 sides that is there.
I mean, if it's
All
just
the
the
area of
surface,
all of them.
that's the surface area of the box.
All you're saying is
If it says surface area of the box, that's the whole area.
Those are the only ones we have.
But that's,
You have these
that's
as well.
the open top.
And the other two.
That's
That's
the
what surface
surface
area
area. It's just talking about the top.
but it's the same.
Alright, why don't we pull this together and see where we can go with this. Surface area. Surface area means if I was to paint all the sides of this box, how much paint would I use, right? That's like the basic definition of surface area. So surface area, let's start with the bottom. What's the area of the bottom? Whoa!
Oh, it's 2x.
No, it's
Whoa!
No, it's not.
An area of the box
Squared.
is x times x squared. So surface area involves x squared, that's the bottom. This side over here, x times y. This guy here, x times y again. The one on the left, the one in the back, You guys are like, we've said it 4 times now. Yes, 4xy. And surface area for the top.
It's open.
Open, nothing.
You have an open top. You are not going to paint the top. Everybody okay? So we've got x squared plus 4xy is equal to 108. Yeah?
Wait, if it's surface area, I thought we don't count the one on the bottom.
No, that's in lateral area. If it said lateral surface area, that means sides.
Okay.
Total surface area, it's sides, top, and bottom. Great question. Everybody go to the surface area? So this is the thing we're going to take the derivative of?
No.
No.
That's what we need to define the next step.
Right, what we're trying to maximize is volume. Get me the volume equation. Volume x, y, which is x squared times y. Great, you guys know what to do. You're going to take your volume equation, you're going to take a derivative, you're going to set that equal to 0, life's going to be good, unless you realize that there's a problem here. We have never taken the derivative when there are 2 variables, yet. That's coming. We're going to call that Wednesday of next week. Right now, volume equals x squared times y. We cannot handle taking derivatives when there's 2 variables. What we need is a way to get rid of one of them. Well, if you divide, then you're just putting it over here, and that's still going to be a problem. Carmen, what are your thoughts here?
That why does you just have one circle?
We know that x squared plus 4xy has to be equal to 108. They gave us this information for some reason. This guy here is called the constraint equation. What it does is it constrains your possible solutions. You can't let x be anything that you want and y be anything that you want. It has to satisfy this relationship that x squared plus 4xy is going to be 108. I can use the constraint here in my optimization equation to get rid of one of the variables. Well, let's look at that constraint equation. X squared plus 4xy is equal to 108. Solve for x or solve for y? Think about the algebra here.
Easy to solve.
The y shows up in one place. It would be a whole lot easier to solve for y than solve for x. Right, so if we do that, I'm just going to do a little side work here. X squared plus 4xy is equal to 108. Solve for y, I'm going to say 4xy is equal to 108 minus 4x squared. No, x squared. So y is 108 minus x squared over 4x. Is everybody okay with that part? So that tells me what y is in terms of x. What I want to do is I want to take this information and change my volume. So rather than saying v equals x squared times y, I'm going to say v equals x squared times 108 minus x squared.
Is that new with the quotient rule when we take the derivative?
So that depends. If you work with it in this form, the derivative rules that we need, product rule, and a quotient rule, unless we see something clever that we can do. Right? Is it legal to distribute the x squared through? Yeah, and then you get rid of product rule. So let's try that. So you're going to get v is equal to, what is it, 108x squared minus x to the 4th over 4x. Not bad. I got rid of product rule.
So now we take a quotient.
Now you use quotient rule unless you know a way to get rid of the quotient rule. I want to be careful. I keep hearing you guys say cancel, and you can do it if you do it the right way. It's probably easiest to think about this as 108x squared over 4x minus x to the 4th over 4x. Because now I'm just going to say, oh, 108x squared divided by 4x is 27x minus x to the 4th over 4x, cancel an x, you're going to get x cubed over 4, which if you guys don't mind, I'm going to write this as 1/4 x cubed. Same thing. That's v. We've only got 2 minutes left. I think you guys know exactly what to do from here.
Derivative.
Take a derivative.
Absolute max stuff.
You're going to take a derivative. Set that derivative equal to 0. Get me that candidate. See what you can do. Alright. B prime 27 minus 3/4 x squared. Set that equal to 0. For all the friends in the fraction killer gang, multiply by 4. 108 minus 3x squared is equal to 0. Divide by 3. We're going to get 36 equals x squared. So x is plus or minus 6. Anybody else getting plus or minus 6? Yeah. So 2 candidates?
Oh my god.
No, one.
Why?
Can't have it.
Think about the context here. X is supposed to represent the length of the box. Negative doesn't make any sense at all. So x equals 6 is the only candidate. Good news. You know what that means? If x equals 6 is the only candidate, then this is the only place where the derivative gets to change sign. And if it's the only place where the derivative gets to change sign, you're either looking at an absolute max or you're looking at an absolute min, and this is why you'd want to do like number line tests and finish it off. I know we were going fast, you guys are fine, there's no homework on this tonight. You got the quiz tonight, that's due Thursday. Life is good. No one cried yet.
Not yet.
Not yet, I'm hoping. There's always Thursday.
I am excited for this stuff. So this is the road list.
And I really think when you look at the materials, the quiz,
Let's go. Let's go.
it's so much nicer. And I'm going fast with the BC kids, and I probably wouldn't give you the challenge problem with the AB kiddos. Hey there.
Don't take my life.
Do you really want that?
Yes.
If you guys like this so much, there's some optimization
Multiplied by
courses.
negative 3/4.
There's a course in optimization.
No, there's not.
It was my favorite course in college.
I talked about this yesterday, but
Good stuff.
about leaving the lines, but
Yeah,
you
It's
just-
good. That's how you can make
My hardest part already passed, so.
Just wait till series.
And all you're
I've
gonna
already
do
seen that.
is email me.
I've seen that.
Thank you, Derek.
Earn a trade.
Trade me what?
That's hard part number 2.
Huh?
I'll go to some advanced science, you go to creative writing.
But then I have to go to fifth period.
That's why you get to creative writing.
What are you guys trading classes?
Yes.
Because they look so much alike, people wouldn't notice.
Yep.